Hello, my name is Fatma Nurbaş.
Hello, my name is Dilar Delan. I will present the project we did for a data mining lesson with my friend. Our topic is to estimate song popularity using regression models. We train a dataset containing song features such as song duration, acousticness, decibelity, energy, K, liveness, loudness, tempo, and make song prediction with three regression models.
Now I will start explaining our code here. We use Google Colab for compiling. Here we imported the libraries we will use, and here we download our dataset from Kaggle and save it as song data. And here you can see first few rows, song name, song popularity, and other features. All of them are here. And here is the info of our song data set. Now we are checking if there is a null value in one of the features columns. As you can see, all of them are 0, so there's no null value here. All the dataset is completely full. Now we are describing the dataset, count, mean, minimum, and maximum. And here we're looking for duplicate values. If we find any duplicates, we are saving them as unduplicated, and then we are removing them from our dataset. And here we are looking for outlier values. If there is an outlier, we are finding and removing them. And here, as you can see, all the numbers are same. So old and new, they are the same data set. So there's no outlier in the data sets. And after that, we are looking for our correlation matrix. As you can see, many values does not correlate with each other. So this brings us to our biggest complicating factor when training the model, because there's almost no correlation, nearly zero relationship around any of the features. So that makes our data sets is a little hard to learn and improve our model. Here is the pair plot. Pair plot is showing the distribution of the relationship between the features. Little, but we can see them. And here we are removing the features that we won't use and creating graphs for every feature that left in our data set. Song popularity, acousticness, danceability, energy, key, liveness, audio valence, time signature, tempo, speechness, audio mode, and loudness, and their respective counts. And here we are doing univariate analysis. It explores each variable in a dataset separately and looks at the range of the values as well as the central tendency of the values. This describes the pattern of response to the variable. Here is the first graph, loudness and the frequency response of each loudness point. And here it's for the danceability and energy. Here you can see the liveness and the frequency, and here you can see the liveness and its counts. It's pretty similar shape. So the next is the popularity histogram. You can see there are lots of unpopular songs in our data sets. If we set our popularity point from the 50%, around here, and you can see there are lots of unpopular songs and less popular songs, and almost none 100% popular songs. And here we are deleting other features that we do not want to include in our models and trainings. And new correlation of our datasets looks like this, a little bit better, I can say. And then we are creating X and Y. Our label is song popularity, of course, and here's the correlation of the X. Then we split train and test. We choose the 80% and 20% as training and testing. And the first algorithm we use is K-NN regression. We fit the model and predict the values, and here's the actual values versus predicted values score. And also we did same thing with residuals. Residual is a measure of the how far away a point is vertically from the regression line. And now onto our second regression model, random forest regression. We fitted the model and predict something. It's also similar to K-NN, but a little better. Here is the predicted values and residuals. And now our third and last regression model, linear regression, is our prediction values and actual values, is graphs, and also residual graphs. And then we use metrics such as mean absolute error, mean squared error, and root mean squared error. And you can see all of them here. Random forest regression, linear regression, and K-NN. You can see all the results here at once. And that completes our work on code. Now Dilara will explain our report and the graphs before more details. Thanks for listening.
I will briefly talk about the graphic and model results in the report. There are introduction and data information sections. Here we visualize the dataset we mentioned in the input and data information section below. First of all, when we look at the images in the dataset, we can say from the correlation graph that there is no similarity between the most of the features. At the same time, when we look at the data distribution of the features, we can see that all of them have an unbalanced distribution, except for the audio mode. Again, on the right, we can understand the irregular relationship between the features from the pair plot graph in the figure. In this part, we perform feature extraction, and in this part, we train the dataset accordingly. In the model selection section, there are the models we trained and their results. The scatter plot we get when we train dataset with the linear regression model is as in the figure. When we interpret the graph by looking at the density of the points, we can say that the prediction accuracy is high where the points are gathered together. In this graph, there are dense points in some regions and single points in some regions. The scatter graph of the K-NN regression model is as in the figure. Here the points are more dense than in the previous model and form a line in a certain region. Accordingly, we can say that the prediction results will be higher than the previous model. Finally, when we look at the scatter graph of the random forest regression model, we can see that it is similar to K-NN, but the points are more dense. By looking at this graph, we can say that the best prediction percentage among the models is inferior to the random forest regression model. Likewise, when we compare the residual plots of the three models, this, and this, the most prominent horizontal line belongs to the random forest model, this, where the residual value is 0. The model with the mean residual values closer to 0 is random forest. That is why it gives the best results. In the model evaluation part, there are the results of the evaluation metrics of the models. When we compare the models according to MSA, MAE, and RMSE metrics, random forest gives the best result. Since our data set is unbalanced, we can say that the prediction percentages are not very good, but the best among these three models is random forest regression. Thanks for the listening.